Division properties of exponents. With this section, we're going to be looking at the different properties of dealing with division and exponents. So there's quite a few properties in this section. The first out of the few that you'll see is called Quotient of Powers property. When you're taking these notes, don't forget you need to write out this box. You'll need to write down the words and the examples as well. So the quotient of two non-zero powers with the same base equals the base raised to the difference of the exponents. That's this property written in words. So what that means is, notice that we have base values that are the same, 6 and 6, and what's different here are the exponents. And what you need to do with these exponents when the bases are the same is you need to subtract the exponents. So it becomes now 6 raised to the 7 minus 4 power, which is 6 to the third power. And so the algebra behind this is if a is a non-zero real number and m and n are integers, then a to the m over a to the n equals a to the m minus n. Just something to think about too with the quotient of powers property is that when they have the same base, like I just showed you, with the same base can be found by writing the powers as a factored form and dividing out the common factors. So here we have bases of 3, we have 5 and 3. Notice how we wrote 3 times 3 times 3 times 3 times 3 5 times. 3 to the third is 3 times 3. Notice we're crossing out, so 3 divided by 3 is 1, 3 divided by 3 is 1, 3 divided by 3 is 1. So what we have left here is 3 squared. 3 squared gives me 3 times 3, which equals 9. And based on the box that I talked to you about, that's the same as 3 to the 5 minus 3, which is the same as 3 squared. So this is the math, two different ways to solve for the quotient of powers property. Let's do some examples here. Here we have a 2 to the 9th, 2 to the 7th. Notice my bases are the same value, but I'm going to be subtracting my exponents. So what we do here is we subtract 7 from 9. So we have 2 to the 9 minus 7, which becomes 2 squared, and our final answer is 4. You need to be writing out all these steps like the notes have shown, and I expect you to do the same thing in your bookwork as well. Looking at B, we have y, and we can think of this as y to the first over y to the fourth. We have the same base, which is y, so now we can subtract the exponent, so y 1 minus 4, which is going to give me y to the negative third. Notice we do have a negative exponent, so we do need to reverse this to have it be 1 over y to the third, and this will be my final answer here for B. Here's some more of those type of examples continued, but we're going to get a little bit more involved working with these exponents with similar bases. Looking at C, we have m to the 5th times n to the 4th. We also have on the denominator m to the 5th squared times n. So looking at this, what we're going to do is we're going to write this out by finding our similar bases with exponents. So when we have 5m squared, remember we're going to multiply those exponents. So what this becomes as the denominator is m to the 10th n, and on the top we have 5m n to the 4th, that stays. So notice how we just simplified down this m to the 5th and 2nd power. Now what we're going to do is we're going to take the bases of m and do 5 minus 10, take the bases of n and subtract those exponents. So what we have is m 5 minus 10 times n 4 minus 1. So we're going to get m to the negative 5th, n to the 3rd. 5 minus 10 is negative 5, 4 minus 1 is 3. Notice m to the negative 5th is negative, n to the 3rd is positive. This is your numerator. this is your denominator. So your final answer is going to be n to the third over m to the fifth. Looking at D, we have 3 to the fifth times 2 to the fourth times 4 to the third over 3 to the fourth times 2 to the second times 4 to the sixth. We have similar bases of 3, so we're going to subtract 5 minus 4. Similar bases of 2, subtracting 2 from 4 here. Similar bases of 4, subtracting 3 and 6. So the way it's going to be set up is 3, 5 minus 4 times 2, 4 minus 2 times 4, 3 minus 6. So what I'm going to have here is 5 minus 4 is 1, so we have 3, times 4 minus 2 is 2, so 2 squared. 3 minus 6 is 4 to the negative third. To write our final answer, we bring that 4 to the third down to the denominator. 3 times 2 squared can be simplified. 2 squared is 4, so we have 3 times 4 as the numerator is 12 over 4 to the third, which is 64. 12 over 64 is your final answer there for D. Don't forget to simplify as well. Now we're going to simplify here, working with scientific notation like you saw in previous lessons. It says simplify 3.3 times 10 to the 6th divided by 3 times 10 to the 8th, and write your answer in scientific notation. So what I'm going to do is I'm going to rewrite this out. So I have 3.3 times 10 to the 6th as my numerator, divided by 3 times 10 to the 8th as my denominator. Look at how we have our bases of 10 with exponent of 6 and exponent of 8. We're going to subtract 6 minus 8, but we're also going to divide this 3.3 divided by 3. So what we have here is we're going to write as a product of quotients. So I just rewrote it out here, but then what I'm going to do is divide. 3.3 divided by 3 becomes 1.1. And then times 10, 6 minus 8 is going to give me negative 2. So I have 1.1 times 10 to the negative second power. So we simplified this expression and wrote it in scientific notation, and that would be my final answer for number 2. Here we have another property. It's called positive power of a quotient property. The words of this is a quotient raised to a positive power equals the quotient of each base raised to that power. So what we have here is 3/5 raised to the 4th power. So what that means is 3 multiplied by itself 4 times, 5 multiplied by itself 4 times. So that is 3 to the 4th over 5 to the 4th. And that's how it's almost like distributing that exponent 4 to the 3 and to the 5. So if a and b are non-zero real numbers and n is a positive integer, then a over b to the nth power is a to the n over b to the n. Here's it broken down a little bit more. A power of a quotient can be found by first writing the numerator and denominator as powers. So here we have 2 to the third, so 2 multiplied by itself 3 times. 3 to the third, 3 multiplied by itself 3 times is going to give me 2 to the third over 3 to the third. Let's do some examples of this here. Here we have 2 to the third raised to the second power, 3 to the second raised to the second power. Notice how we have these two exponents. Remember, with these exponents we multiply. So this is going to be 2 to the 6th over 3 to the 4th. So let me show you this. So notice how we multiply 2 to the numerator exponent and the denominator exponent. So we get 2, 3 times 2, 3, 2 times 2. So we have 2 to the 6th over 3 to the 4th, which simplifies to 64 over 81. And that would be my final answer for A. Now for B, we have AB to the 4th extended to the 5th power, C to the 2nd, D to the 3rd raised to the 5th power. So what I'm going to do is I just rewrote this out here for this situation. And what we have to do is this fifth power here gets distributed to the a and to b to the fourth, along with the bottom c to the second, d to the third. This fifth exponent, fifth power, gets distributed to the bottom as well. So what I have is a to the fifth times b to the 4 times 5. For the denominator, I have c raised to the 2 times fifth power times d 3 times 5. When I simplify that down, it's going to be a to the fifth times b to the 20th, because 4 times 5 is 20, c to the 10th, because 2 times 5 is 10, times d to the 15th, and this will be my final answer for B. For C, we have a to the third, b to the third. We're going to distribute this 3 here and to the b, so distribute 3 to the a, 3 to the b. You also distribute this 3 to this bottom, a squared, and the b squared. So here I just rewrote it out. So what I have is a to the third times 3 times b to the third over 2 to the second times 3 times b to the second times 3. So what I'm going to end up with is a to the ninth times b to the third over a to the sixth times, a to the sixth times b to the sixth. But notice how we have same bases with the exponents, so what we can do here is do a 9 minus 6 and b 3 minus 6, which is going to become a to the third over b to the third, and this will be your final answer for C. Last property for this section is the negative power of a quotient property. This is when a quotient raised to a negative power equals the reciprocal of the quotient raised to the opposite positive power. So here what we have is 2/3 raised to the negative fourth power, and all you do, like they said, is you take the reciprocal of the quotient raised to the opposite positive power, sorry. So I switch this. I take the reciprocal, and then my exponent becomes positive. So instead of it being 2/3, it's going to be 3/2. Now my negative 4 becomes positive 4. So what it is 3 to the fourth over 2 to the fourth. The algebra behind this is if a and b are non-zero real numbers and n is a positive integer, then ab raised to the negative nth power, we take the reciprocal, and the exponent becomes positive, so it's b over a to the nth. So b to the n over a to the n. So let's do some examples here. So looking at a, we have 4 over 3 squared raised to the negative third power. So what we're going to do is we're going to take the reciprocal, so we flip the fraction. So now what we have is 3/2 over 4 raised to the positive third power. Then we simplify this down. So what it is, 3 squared is 9 to the third and 4 to the third, and we can take that a step further. 9 to the third is 729, 4 to the third is 64, and this will be my answer for A. Looking at B, we have 2a over b squared c to the third power cubed raised to the negative fourth power. So what we have to do is take the reciprocal here, so we have b squared times c to the third over 2a, all raised to the positive fourth power. Now what we need to do is we need to distribute that power of 4 to each exponent inside the parentheses here. So what we have is b squared to the fourth. 2 times 4 is 8, so b to the 8th. 3 times 4 is 12, so c to the 12th, over 2a to the 4th. So 2 to the 4th is, you can just write 2 to the 4th, times a to the 4th, which is 16a to the 4th for the denominator. So b to the 8th, c to the 12th, over 16a to the 4th is your final answer there for B. C, we have s over 3 raised to the negative second power times 9s squared over t raised to the negative 1 power. We have to take the reciprocal of each fraction because we have our negative exponents. So what this is going to be is 3 over s squared